Hello, I'm Simon. In the last video I was talking about Vaadin. Vaadin uses Spring Boot by default. But hey, what is Spring Boot? In this short introduction, I will explain what Spring Boot is and how it is related to the Spring framework. Well, let's talk about the Spring framework. 20 years ago, Rod Johnson wrote a book, J2E Design and Development. 20 years ago, J2E was very popular, and Rod Johnson wrote about how to efficiently develop business applications using J2E. But he wasn't so happy with the J2E framework, especially with the enterprise Java beans, because they were heavyweight and couldn't be tested without the J2E application server. So in his second book, together with Jürgen Höller, he wrote about J2E development without EJB, and at the end he was talking about Spring Framework. The Spring Framework is a dependency injection framework, and in the early days of dependency injection, this principle was called inversion of control. So what is inversion of control? Inversion of control means that you have beans. In terms of Spring, a bean is a plain old Java object, so it's a lightweight component in contrast to the EJBs from J2E. And beans define dependencies through constructor arguments, fields, or setter methods. You don't have to instantiate the beans by yourself. This is done by the Spring container. So he checks the metadata that you configure, usually these days with annotations, and then creates the beans for you. It also injects the dependencies into the beans, so that's why it's called inversion of control. If you have a look at the Spring framework, we see this picture here. It's a very old picture. It's just some parts of the whole Spring framework, because the whole Spring ecosystem is huge. You can do a lot of things with it. That's just a small part of it, but a part that is usually used if you're creating Spring applications. So what we see here on the picture, we see that Spring has a core container where the beans are, where contexts are managed. Context means that beans have a life cycle. By default, Spring beans are singletons, but you can change to another life cycle, whatever you want. So for example, if you use Vaadin, we have another scope like UI scope, possession scope, or route scope, for example. So this defines the life cycle of the bean. And we have a Spring expression language that you often use in combination with configuration, for example, where you can use an expression language. Then below that we see test. So test was very important already from the beginning of Spring, that all the components must be testable. And Spring comes with a very useful test environment. We will see that when we look at Spring Boot. Then we have some cross-cutting concerns like aspects, instrumentation, and event messaging. And on top, we have just two parts that you can use if you use Spring. On the right-hand side, we see web. Web is the traditional web part with servlet-based. This is thread-based, and usually we use a container like Tomcat, for example, or Jetty. But today we also have a reactive style of programming. That's not on the picture here. That's also an alternative to this thread-based model. Then on the left-hand side, we see part that's data access and integration. We see things there like JDBC. We see R mapping, that's usually JPA with Hibernate. We see messaging with Java Messaging Service, and we see everything that goes with transactions. Now, how do we start with Spring Boot? The easiest way to start with Spring Boot is to go to start.spring.io, and we'll find the Spring initializer. On this page, you can select various things. You can select the Maven or Gradle project. You can choose from languages, Java, Kotlin, Groovy, and you also can choose the Spring Boot version that you want to use. We are going for 2.6.4, that's the most recent released version here. Then you can configure the metadata, so we leave everything as is. We can also change packaging. Packaging is either an executable jar or a WAR file that you want to deploy in an application server. Then you can choose the jar version. We are going for the most recent version 17, and that's it from the setup of the project. Now, the difference between Spring Framework and Spring Boot is that Spring Boot is an opinionated framework. That means there are a lot of auto configuration already there. For example, you could have a data source configured for you, and to take part of this auto configuring and also the dependency management, you can add dependencies. And dependencies in Spring Boot are usually so-called Spring Boot starters. That means there are predefined dependencies that contain dependency management and configuration. For that, you can use the add dependency link here. And now you see that there are various dependencies that you can use. For our example, we just need Spring Web that will add Spring MVC. We can build RESTful applications with it, and it will use Apache Tomcat as an embedded container. So we choose that. And finally, we can generate the project right from here. If you have a look at this dependency section again, we see that there are a lot of possibilities that we have. Here we also have Vadin that we have seen in the previous video, but there are other possibilities, for example, to create server-side rendered web applications with Timely, FreeMarker, Moustache or Groovy. We have security starters here. We also have SQL database access with JDBC, JPA. We have all the Spring Data libraries like Spring Data JDBC or R2DBC. We also have Juke. Juke will be covered in one of the next videos. We also have Flyway that we will see in the next video as well. And then we have some database drivers like H2, DB2, SQL Server, MySQL, Oracle, Postgres, and so on. There are also NoSQL databases supported, and we also have support for messaging, traditional with RabbitMQ or ActiveMQ, or also event driven with Apache Kafka, for example. Then we have also Spring Batch. That means Spring Boot is not only a framework that allows you to create web applications like microservices. You can also create batch applications with it. We also have on this page Apache Camel. Apache Camel is an integration framework that you can use. Spring Integration is there as well as an alternative to Apache Camel. We have schedulers, we have mail senders, so we have literally everything that we may need to build a application. And no matter if it's a web application, a batch application, or something else. So now let's go ahead and generate our first Spring Boot application. After the download has been finished, I've opened the project in IntelliJ. I use IntelliJ, but you can use any IDE that you like. No matter if it's Eclipse, Visual Studio Code, or NetBeans, they will all work. Now, let's have a look first at the generated project. As we've selected Maven as the build tool, Spring Boot Initializer also created the Maven wrapper files. So these two files, the mvnw files, are used to build the project. You can use them, and it will download the Maven version. So you don't have to care about installing Maven first. The most interesting thing about the project first is the POM XML. It's a Maven project, and you see that it has a parent. And the parent is Spring Boot Starter parent. So obviously, a Spring Boot comes with a parent that may contain some configuration. So let's have a look what's inside this Spring Boot starter parent. We can navigate by Control-click, by the way, in IntelliJ. And then we see that we have here some configuration. For example, we have properties set. So default seems to be Java version 1.8. We have selected 17. We will see that right away that this is overridden in our own project file. And then there are some configuration, plugin management stuff right here. That's not that interesting. What's more interesting is if you go to the parent of this Spring Boot starter parent, that's the Spring Boot dependency. And here we can see all the versions of all the libraries Spring Boot knows. So here in the properties section, we see the versions, like we see ActiveMQ, AspectJ, we see some Commons project, we see Flyway here, we see Hibernate, we see a lot of other stuff right here. So this is the dependency management of Spring Boot. So Spring Boot comes with versions that are used by Spring Boot and are tested together. So you don't have to write down any versions in your POM XML as long as the dependency is in the Spring Boot dependency project. And if you go down here, what I told you before, there the Java version is overridden. We use Java 17. And then we have some dependencies. First of all, we have the dependency that we have selected. So we have selected Spring Boot Starter Web, and that's now here as a dependency. And we see in this icon here on IntelliJ, we see that the version comes from above, and here we see that it's 2.6.4. An additional dependency that the initializer added without asking is the Spring Boot Starter test that is used for testing our application. So it has a scope test. It will not be bundled in the project jar at the end. And then we have a plugin section with the Spring Boot main plugin that will be used to build the project. So that's everything that we need to use at the moment. Maybe we could have a look at the Spring Boot Starter Web project to see what this includes. Here we see that there are some dependencies included like JSON, Tomcat, the Spring Framework, Spring Web, and the Web MVC project. So this has everything that we need to run a simple web application. Now, if we go to the source directory, we have the source main directory. That's the common main project layout. And we have, first of all, a Java directory with a class. And this demo application is the starting point of every Spring Boot application. It has a main method, so we can run this class. So we don't need to have a Tomcat application server running and we deploy the application there. We just have to start the main method and it will run our application. What we see is that the demo application has an annotation, Spring Boot application, and this Spring Boot application will configure the whole environment. So by default, Spring Boot will scan the class path starting from com example demo. So this is our root package, and will find all the components that are below the demo application in our case. So if we have a look at the Spring Boot application, we see that there are other configurations on this annotation. So we see here Spring Boot configuration, enable auto configuration. This is used at Spring Boot works, and we have this component scan that will start right on the level where our Spring Boot application is. On the other hand, we have a resources directory, and there is the default Spring Boot configuration file located. That's the application properties file. So there is nothing inside. We will have other videos about how to configuring Spring Boot applications, mostly in combination with other frameworks like Vadin and Chook. There we will see the application property files. For now, we don't need any configuration. We just have our demo application here. And then we have the test directory with the demo application test. That's generated by the Spring initializer as well. And here we just see a test that has no assertion, but it's annotated as a JUnit test and has the Spring Boot test annotation. That means that if I run the test, it will start the Spring Boot environment and do all the Spring Boot magic and configuration, and then we can use that to run our application in a test. There are other test annotations like data JPA test. These are so-called test slices. We also can have mocks. We can have our MVC framework mocked, for example. These are all possibilities that we have. For now, we don't need that at all. We just go ahead and create a simple service. And this could be a greeting service that says hello. And to make this greeting service a Spring Bean, as we have talked about dependency injection in the introduction, we have to define that this greeting service is a bean. And this can be done with annotations. And for example, there is a service annotation. It's all located in the Org Spring Framework stereotype. A service is a specific annotation from a component. So the base would be a component. So that's all-purpose annotations. With the service, we say this one here is a service, for example. And then we can create a method like something that says hello, like this. And this will take a name and return hello plus the name. So now we have a Spring Bean defined. IntelliJ sees that this is a service and would also have the possibility to navigate where this could be used. What we like to do now, we would like to create a test for that, and so we can create a test right from here. We choose the hello method to test. And then we go ahead and add the Spring Boot test annotation on that level. And then we can use dependency injection. So we use field injection here. In the introduction, I said that the preferred way for dependency injection is constructor injection, but we have a test class here, so we have to use this field injection. And here we can inject our greeting service. And then we can call the greeting service hello, pass the name like Simon, and then we should get the greeting. And now we have to make sure that this greeting says hello Simon, so we can use assertions. Spring Boot by default, or Spring Boot test by default, uses JUnit 5 and comes with so-called matcher frameworks like AssertJ. And we're going to use AssertJ. So we call assert that and pass the greeting. And we import it from AssertJ core API. And then we say it must be equal to hello Simon, like this. And then we can start our test class right here from the development environment. And now you can see that this starts the Spring Framework and it's green. I'm lucky that I wrote all correctly. And we see that the Spring Boot is started. And so we have a fully Spring Boot environment to do our tests. Now, as we have selected to create a web application, we want to create a simple REST controller that uses this greeting service. So we can create a new class and call it greeting controller. And this time we need another annotation. And this one comes from the web framework of Spring. It's a REST controller annotation that first of all makes the greeting controller a REST controller, and on the other hand it also makes it a Spring Bean. So here we want to use our greeting service, So we can create a final member in this class and then do it in constructor expression. So Spring Boot will inject it right into the controller constructor here. We also see that with the icon that is created from IntelliJ. And then we want to have a method that returns just the greeting. So here we have a method called getGreeting, for example. And we can pass a query parameter that will be a request param in Spring MVC, and we use the name, and then we can return the greeting service, hello, and pass the name. Now this is just a plain method. It has an annotation to use the query parameter with this request param syntax. By the way, if we don't pass any name of the parameter, it will have the same name as the method parameter. And then we have to add a get mapping annotation and say on which path it should be accessible then. So that's more or less that we have to use. We also see here an icon with the globe. So that means IntelliJ recognizes that this is a REST controller. And then we can start the application. So we can run our demo application. And this will start Tomcat. We see here that the Tomcat is started on port 8080. And it took 1.5 seconds, so it's very fast. And then we want to access that, and IntelliJ integrates an HTTP tool that you can use to test REST APIs. And here we can choose generate request in HTTP client, and then it generates such a method. And here we can pass the name parameter, Simon again, and then we can execute that, and we see the result here down is the HTTP headers with the return code 200, so everything is okay. And here we see the body, that's hello Simon, so everything works as expected. So that was a very short introduction of Spring and Spring Boot. I hope you get an impression how easy it is to create applications with Spring Boot. Because of the dependency management and the auto configuration, you don't have to care about all these things. You don't have to start your own application server and deploy your application. You will get a fully self-contained application at the end that you can run right from your IDE. Also, testing is very easy. The Spring Boot starter test adds all the required dependencies and will start a fully Spring Boot application environment if you need that for testing. That's it for this session. Thanks a lot for watching, and don't forget to like and subscribe.